Okay, so over here, as I said, we're going to see a demonstration of this Word2Vec, right, how it is done. So I have a very simple code here, just 5 cells over here for us to go through, right? So let's start over here, then I will show you what we are doing, right? So what I'm going to do is that I'm going to first use the NLTK, right? NLTK to demonstrate that for you to see. I mean, there's also Gensim over there. I will show you that one as well. Okay, but now I'm showing you the NLTK, right? So for NLTK, I mean, these are things that you need to download in order to proceed, right? So import NLTK, download the punct, download the stopwords, right? These are things that we have used over and over again, right? And then over here, I'm using the Gensim over here. Okay, so as you can see, so gensim.models import Word2Vec. Okay, and then from NLTK.corpus import stopwords. So I'm using these two things over here. I'm using the Word2Vec from Gensim, then I'm using stopwords from NLTK. So you see how I'm missing the two libraries over here, right? And I'm importing regular expression over here, right? So this is just a short test that we have over here, right? So this is going to be our corpus, right? This is going to be our corpus over here. All right. So you can just, this is just a test, right? There's nothing, special about this. You can just go to Wikipedia and download any or copy any text and use it for your own practice. Okay. So over here we do the basic pre-processing over here, right? We just do the basic pre-processing. So first what I'm doing is that I'm just removing I'm using regular expression here, removing any numbers from 0 to 9, okay? Any numbers from 0 to 9. And then I'm passing in my paragraph because that's where I'm going to remove those numbers 0 to 9. So if you find any digits in there, right? For instance, we see that we have 10 over here, we have 30,000 over here, right? We have 5 over here. I'm taking care of that, right? We have 18, 75, 57. I mean, this one depends on your use case. There are some use case you will not need to do this, right? Because the numbers will have meaning, right? For instance, here, this is a date, okay? So if I remove the date, there will be no meaning, to the sentence as it's supposed to be. So in such case, I might not want to remove the numbers, okay? So depending on the use case, right? In this case, I just removed them. And then any special characters and unnecessary spaces in there, I'm just removing. And most importantly, you need to convert everything to lowercase. Okay, convert everything to lowercase because you don't want words like maybe say power with capital P to be confused with power, all right, small p. They are all the same thing, right? They're all the same thing. So when I'm working on it, I want all the capital letters to be converted to small letters so that if there's power, if I'm picking unique words, power should be the same thing as power, okay? They shouldn't be copy power this 2 times or 3 times or how many times. It should be the same thing, okay? So you need to convert everything to lowercase, right? And then once I do that, then here I tokenize it, right? Remember, I've stored everything in text, okay? So I tokenize the text. And you know what tokenize means, right? Just chunking all the words into individual tokens, right? And then here I'm tokenizing them into the tokens, the individual words or tokens. But here I was using sent_tokenize, right? I was tokenizing them based on the sentence. You can skip this step, right? And then do it straight away, just tokenizing the words instead of tokenizing the sentence and then tokenizing the words, right? You can just tokenize the words straight away. You can do that one as well. All right. So here I'm removing the stop words. So if I pick any word in my sentences, okay, I check if it is in the English stop words, then I drop it. If it's not there, right, if it's not in there, then I store it. All right, then I store it. So once I do that, then I can use the Word2Vec that we imported above. Okay, this Word2Vec that we imported, right, this thing we imported over here. So I'm using it over here, right? That's what I'm using, Word2Vec. And I'm inside there, I'm passing in my sentence, and then I'm saying the minimum count equals 1, meaning that if the word is present in my sentence and I cannot count it, let me do this. If I cannot count it more than 1 times, then I'll drop it because that is not that important over there. Okay. So once I do that, I store everything in model. All right. I store everything in model. So let me run this one over here and see. All right. Good. Now, once I do that, now I'm going to show you all the vectors that we have, okay? All the vectors that we have been able to get. That is the word vectors, okay? The Word2Vec. Remember, we have used Word2Vec function over here to work on the sentences. So we are supposed to get the word embeddings. Okay, remember, if we use the Word2Vec, the resource is the word embeddings. Okay, that's what we saw earlier on over here. Okay, we are supposed to get word embeddings. Okay, so let's see how that goes. So here, in order to get that, I'm doing model. Remember, we have stored everything in model. Okay, so I'm doing model.wv, which is nothing but word vectors. Okay, dot vectors. Then that will give me the word embeddings. So if I print this one out, this is it. You see that I have all the word embeddings over here, right? This is quite a lot because I've actually there's a break over here, right? You can print the length of this one. Okay, if you print the length of this one, you will see how many are there. 123 word embeddings over there. Okay, so that's basically what you have. So let me let me take them off and then print the vectors for you to see. Okay, so that's basically what we have. Okay, if I can also print the keys, right? The keys are nothing but the individual words, right? For instance, over here we have the words like, say, queen, man, woman, dog, blah blah blah. We have it. So let's print that one as well and see. Okay, so if I run all of them, see, this is the keys. Okay, let me even, okay, it's fine. Let's print, or I can just comment this one out, right? And then I'll run for you to see. So this is the keys. We have 3 versions, visions, India, .es, history, comma, people, and so on and so forth. Okay, so these are the things that these are the keys. Okay, so what I'm going to do is that I'm going to print all the keys and also all the, let me comment this one out. Okay, I'm going to print the keys and the words together. So if I have the words and then the keys, I should print them together, right? So let me actually do it this way. Let me switch this thing, and then I'll do it this way. I'm going to print the keys and the vectors. Okay, the keys and the vectors. So let me run it. Okay, so this is basically what you have. So if you pick, let's go all the way up because it's quite huge. So let's go all the way up. Let me screw it up. Okay, so first, if you pick 3, right? If you pick 3, this is the word embeddings for 3. Okay, all the way up to here. Okay, and then the next one is what? Visions. Okay, and visions is having its own word embeddings all the way to, let's see, all the way to here. Right, visions from here all the way to here is the word embeddings for visions. Word embeddings for India is from here all the way to here. Okay, and then the next one will start, let's see, from here, yes, right, like that. So I mean, you have the you get the idea, right? You get the idea. So it's basically like this. Okay, basically like this. So based on the features, right? So we have, so for instance, if this one was say India over here, right? So the word embeddings are like this, like something like this, all the way to the length of the features that we have. Okay, something like that. That's what you are seeing over there. All right. Okay, we can print just one. For just one word. So, for instance, over here, right? You can just pick any word and then you print the word embeddings or the vector for it. Okay, so here I just pick history, right? Because history is actually here. Okay, so I just pick it, or maybe let me pick a different word, say captured. Okay, now if I go here, if the word is starting with capital, you need to make sure that you change it to lowercase, because we have already converted everything to lowercase over here, right? Somewhere. Let's see. Here we have converted everything to lowercase. So if you put capital letters here, it won't work. So this is the word embeddings for captured. Okay, word embeddings for captured. If we pick any other word, so let's say let me pick any word. I want a word that starts with capital. Okay, now this one, right? Let's go. Or maybe Alexandra, something like that. Let's see, Alexander. Okay, let's run and see. Okay, Alexander is not in the vocabulary because it's starting with capital. Meanwhile, we've converted it to lowercase. So we need to convert this one to lowercase, and then we have the embeddings. Okay, we have the embeddings. Now, one also interesting thing is that we say that the Word2Vec helps us get the distance, right, to get the similar words. For instance, if we search for kin, the nearest word should either be maybe queen or should be man or something like that. Okay, not that we search for kin and then maybe plastic bag will come. They are not very close. Okay, or maybe we search for kin and then a cat will come. Okay, no, what is closer is something like queen, man, woman, something like that. Okay, or palace, right, royal, something like that. Okay, so in this case, this one is a very small data set, so it's possible for it to make some sort of silly mistakes. But I mean, regardless of that, let's check and see. So in order to do that, you do model.wv.mostSimilar. Okay, so here I'm checking the most similar word of power. So let's see that. Okay, so you see that the similar word to power is invaded. Okay, it's invaded because power comes with invasion. Because this is I mean, the words over here relates to slavery, invasion, fight, war, those kind of things, right? Something like that. So I mean, it's likely that the word power will come with something like that. Will come with invaded. Okay, let's see a different word over here. And then we will see, maybe we should check for maybe something like, maybe let's see history, right? Let's see history, or maybe conquered. Let's see conquered and then see. Let's see the word that are similar or closer to conquered. Let's run that and see. Okay, so conquered, got, space. You see that something like that, life, independence. These are words that are closer to conquered, right? Let's see word like let's go and pick some word over here and see. Let's pick word like war. Let's pick word like war and see what are the words that will come close. I need to make sure this is in small, lowercase. Okay, hand in hand, yes, nuclear, right, fortune, others, great rate, calm people today, something like that. Okay, so I mean, I think nuclear makes sense, right, more sense. And then since this one is a past history, right, so years will be there, and then most of the time they will be talking one-to-one or hand-to-hand, so that makes sense. Okay, that makes sense. So these are I mean some of the things that Word2Vec help us to do. Okay, so it helps us to put the context into play instead of just ignoring everything and then just giving them based on the frequency of them. Okay, based on the frequency. See, yes, war, come, freedom, history. Is it that they actually make sense? Okay, it actually makes sense. So basically, that's what you're going to be doing. Okay, you'll be generating word embeddings using Word2Vec. All right. So there's one more which I have to show you, which is Glove. Okay, which is Glove. So we're going to see the Glove model in the next tutorial. Okay.